Greetings of the day. Myself, Nehru Kandasamy, faculty from Electronics and Communication Engineering. My topic is multiplexer. First, what is meaning of multiplexer? Multiplexer is one type of combinational circuit. It consists of two power n inputs, one output, whereas n number of selection lines. In short form, I represent MUX. In general, any size of multiplexer is consist of 2 power n inputs, one output, n number of selection lines. For example, we are going to discuss about 2:1 MUX. Then number of data inputs are 2. I can name it as I naught, then I1. One output, so I can name it as Y, and then the number of selection lines are 1. So that is will be I name it as S. Because why it will be 1 means the 2 power 1. So where 1 is the number of selection lines. So this is will be the size of 2:1 MUX. Now I am going to write the logic expression for 2:1 MUX. So output Y is, so when S is 0, we are going to select I naught. When S is 1, we are going to select I1. So the logic expression for 2:1 MUX is Y equal to S bar into I naught plus S into I1. So now very clear information. So here we need AND gate, and then we need one OR gate and one inverter. So for this case, so when S is 0, then the complement of 0 is 1. Then I naught it will be passing to the output. In other case, when S is become 1, then this inverter output is become 0. Then the second AND gate it will be enabled. Then its passing output is I1. So based on that selection lines, you are selecting the data inputs either I naught or I1. That's why other name of the multiplexer is also called as data selector, because the data is selected based on the selection lines. The next example is 4:1 MUX. The first one is a block diagram of 4:1 MUX. So it consists of 4 data inputs, namely I naught, I1, I2, I3, and then one output, that is will be Y. So now it's very clear. So the general definition of multiplexer is 2 power n inputs, one output, where n is the number of selection lines. So for here the size is 4:1. So 2 power n will be written as 2 power 2, 1. So it's very clear. So the number of selection lines are 2. So I can name it as S1 and S0. So this is will be indicates that LSP, and then this is will be indicates that MSP. So here the number of selection lines are 2. Then 4 possible combinations. This indicates LSB, least significant bit, and then S1 it will be the most significant bit. So the four possible combinations are 0, 0. The next one is 0, 1, 1, 0, 1. Then output is the first 0, 0. The output is Y0. Then that second case, if my selection lines are 0, 1, it's selecting the I1 as a output. In third condition, so if you go with that 1, 0, then I2 it will be my output. Then fourth case, 1, 1, then I3 is my output. That's why I will written here. So the output is nothing but the first case I0, and then the second case I1, and then third is I2 and I3. So this is will be call it as a truth table of 4:1 mux. Next I will be moving into that logic diagram of 4:1 mux. Before going into that logic diagram, I will write expression of 4:1 mux. S1 bar, S0 bar, I0. That is first term. The second term is 0, 1. So S1 bar, S0, I1. Then the third term is S1, S0 bar, I2. And then the fourth term is S1, S0, I3. So first term, it will be consist of three variables. So all it will be in product term. So I am going to use 3 input AND gate with 2 inverters. The inverters is for S1 and S0. S1, S0. The another one is will be the data input. 3 input AND gate. So the output of that AND gate is S1 bar, S0 bar, I0. This is the first term realization. The second term is S1 bar. So already we have inverter S1 bar. Then second variable is S0, and then third one is data input I1. Then third term is S1, S0 bar I2, S1. Then S0 bar. So already we have inverter. This is S0 bar, S1. Then data input I2. So again 3 input AND gate. So here the logic expression is S1 bar, S0, I1. Then third is S1, S0 bar, I2. Then fourth term, the output is S1, S0, I3. So that will be the S1. So I take it from here. The next one is S0. Then third one is the data input I3. Then output of the AND gate connected to OR gate. This is OR gate, the 4 input AND gate. So this is the output of the 4:1 mux. So the logic expression is S1 bar, S0 bar, I0 plus the next term is 0, 1. So S1 bar, S0, I1. Then the third term is S1, S0 bar, I2. Then fourth term is S1, S0, I3. So based on the selection lines, the one output of the AND gate is 1. The other 3 AND gate outputs are 0. For example, if you want to select the third data input as output, then your selection lines are 1, 0. Suppose if you want to select the fourth one data input as output, then the selection lines are 1, 1. Suppose you want to go with the first data input as output, then the selection lines are 0, 0. So this is the idea of the 4 is to 1 mux. In similar way, you can extend to 8 is to 1 mux. The first one is a block diagram of 8 is to 1 mux. So 8 data inputs named as I0 to I7, and then one output named as Y. Then it 2 power 8 will be written as 2 power 3 and 1. So here very clear, the number of selection lines are 3. The first one is S2, S1, S0. This is LSP and this will be a MSP. So LSP stands for least significant bit, and MSP it will be stands for most significant bit. So the first two combinations are 0, 0, 0. The second one is 0, 0, 1, and then third one is 0, 1, 0. Fourth one is 0, 1, 1. Fifth one is 1, 0, 0. Sixth one is 1, 0, 1. Then seventh one is 1, 1, 0, and eighth one is 1, 1. When all the selection lines are high, then the output is I7. When all the selection lines are 0, then output is I0. So the logic expression of 8 is to 1 mux is S2 bar, S1 bar, S0 bar into I0. First term. Then second term is 0, 0, 0, I0. The next term is 0, 0, 1. So S1, S2 bar, S1 bar, I0, S0 into I1. Then third term is the 0, 1, 0. So S2 bar, S1, S0 bar, I2 plus S2 bar, S1, S0, I3. Then the next term is S2, S1 bar, S0 bar, I0 plus S2, S1 bar, S0, sorry, will be replaced I4, and then this is I5 plus S2, S1, S0 bar, I6 plus S2, S1, S0, I7. This is the logic expression for 8 is to 1 mux. So total 8 minterms. When you are going with that, all the selection lines are high. You are going to select I7 as output. If you are going with that 1, 0, 0, then you are going to select the I4 as output. The similar way you can select the whatever the data input it should be required for output. Then the next step is the logic diagram of 8 is to 1 mux. So totally it will be consist of 8 AND gates, 4 input AND gates. So the first one is S2 bar, S1 bar, and then S0 bar into I0. The next one is S2 bar, S1 bar, S0, I1. The similar way you are using 8 4 input AND gates and connected to the OR gate. This will be the logic diagram of 8 is to 1 mux. Next, we are going to discuss about that how to realize 4 is to 1 mux using 2 is to 1 mux. So first you want to write the expression for 4 is to 1 mux, the logic expression. We have already discussed the logic expression. So S1 bar, S naught bar I naught plus S1 bar S naught I1 plus S1 S naught bar I2 plus S1 S naught I3. So this is the logic expression for 4 is to 1 mux. Now we are going to realize using 2 is to 1 mux. So you have idea for 2 is to 1 mux, the number of selection lines is 1. So you are going to expand, here the number of selection lines are 2. So you are going to expand either with the help of S1 or S0 with true form and its complement form. So now I am trying to expand this 4 is to 1 mux by using S1 with complementary form and true form. So the idea is I can take the S1 with the complementary form first. After that I am going to expand with the true form. So now if you take S1 bar outside, then S0 bar I0 plus S0 I1. So these two terms, the common variable is S1 bar, then the remaining is S0 bar I0 plus S0 I1. Similarly for third and fourth term, the common variable is S1. So the remaining terms are S0 bar I2 plus S0 I3. So which variable you are expanding, that is will be the outer one. So here the 2 is to 1 mux. The selection line is S1. Now that is one selection line. So you have 2, either it will be that S1 is 0 or S1 is 1. So now that S1 is 0, you are going to select this box as a first. Then S1 is 1, you are going to select this box. Now here the number of selection lines is only 1. Then the variable is S0. So here true and complementary form. So this is will be a true form and this is will be the complementary form. So true form means you are going to select I1. Then complementary form means you are going to select I0. Then the output it will be connected to the 0. Similarly the next, the selection variable is yes not. Then again you have two forms. One is will be the true form and complementary form. So complementary form means you are going to select the data input as I2. Then true means you are going to select I3. Then output will be connected to here. Then this will be the final output. So this is what I want to realize 4 is to 1 mux using 2 is to 1 mux. So first you want to write the expression for 4 is to 1 mux. Then you are going to expand with the help of 2 is to 1 mux. So the idea is first you want to consider to expand with the help of either S1 or S0. So here I am trying to expand with the help of S1. The same way you can try for S0 also. This is what you can realize, but the final conclusion is you want to realize 4 is to 1 mux using 2 is to 1 mux. So the number of 2 is to 1 mux are 3. So the number of 2 muxes are 3. So this is the idea of that how to realize 4 is to 1 mux using 2 is to 1 mux. So next we are going to discuss about that how to realize 8 is to 1 mux using 4 is to 1 mux. So first you want to write the logic expression for 8:1 mux. 8:1 mux, the number of selection lines are 3 and 8 data inputs, 1 output. So the logic expression for 8:1 mux, S2 bar, S1 bar, S0 bar into I0. The second condition is 0, 0, 1. So S2 bar, S1 bar, S0, I1. Then third one is 0, 1, 0, 0, 1, 0. Then the fourth term is 0, 1, 1. S2 bar, S1, S0, I3. Then the fifth term is plus, fifth term is 1, 0, 0, 1, 0, 0, I4. Then the next term is 1, 0, 1. The next term is 1, 1, 0. 1, 1, 0 into I6. Then the last term is 1, 1, 1. So now here is 8:1 mux using 4:1 mux. So I go with that truth table for better understanding. So if you observe closely, uh, the first 4 combination and then the second 4 combination, the S1 and S0 are same, but only the difference is S2. So from min term 0 to min term 3, S2 is 0. Min term 4 to min term 7, S2 is 1. So now I am expanding that. That is will be the outer one. That is will be S2. Then one selection lines. We have 2 possibilities. The first possibility is 0 and then the second possibility is 1. Then S2 is 0. Then you are going to select this 4:1 mux. Then S2 is 1. You are going to select second 4:1 mux. So now I am going to represent the first 4:1 mux. So the selection lines are 2 selection lines, S1, S0. Similarly, the selection lines are S1, S0. This output we can connect it to here because the S2 is 0. So for the second 4 possible combinations, the min term 4 to min term 7, S2 is 1. So I am going to connect this output to input. So here the outputs are, when all the selection lines are 0, the output I0. 0, 0, 1, I1. 0, 1, 0, I2. 0, 1, 1, I3. 1, 0, 0, I4. 1, 0, 1, I5. 1, 1, 0, I6. 1, 1, I7. So now it's very clear. So this one it will be the first 4:1 mux. So now the data inputs are first 4 data inputs. So I0, I1, I2, I3. Then this is will be the second 4:1 mux. So now the data inputs are I4, I5, I6, I7. Then output it will be. Now for 8:1 mux, you need 2 4:1 mux and plus 1 2 is to 1 max. So clear? So 8 is to 1 max realized by using 2 4 is to 1 maxes and 1 2 is to 1 max. You want to expand with the help of S2 initially because the first min term 0 to min term 3 S2 is 0. Then from min term 4 to min term 7 S2 is 1. So first I try to expand with the help of S2. So that is will be the outer one. When S2 is 0, it's going to select the first 4 is to 1 max. The first 4 is to 1 max, the selection lines are S1, S0. The corresponding data inputs are I0, I1, I2, I3. Then second 4 is to 1 max, the data inputs are I4, I5, I6, I7. So this is what how to realize 8 is to 1 max using 4 is to 1 max. So next we are going to discuss about that how to realize some combinational circuits using 4 is to 1 or using 2 is to 1 max. So first I am going to discuss full adder using 2 is to 1 max or 4 is to 1 max. Full adder using 4 is to 1 max. First, we should have idea about that. What is the logic expression for 4 is to 1 max, or you want to know that what is the truth table of full adder. So first I am going to go with the truth table of full adder. So full adder consists of 3 inputs, but it will be call it as 1 bit adder because the size of the inputs is 1 bit. Then 2 outputs, sum, carry, then truth table of 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1. Thus in general n inputs having 2 power n combinations. So n inputs having 2 power n combinations. Here the number of inputs are 3. So you have 8 possible combinations from min term 0 to min term 7. Then the output of sum and carry is 0 0 for min term 0. The next one is sum is 1, carry 0, then 1 0. Here if you add all the individuals, the resultant will be a 2. So you can't represent in single bit. So this is will be LSP bit, it will be call it as sum. Then this is will be call it as carry. So the idea is if you are adding all the individuals, the result is exits 1, then the carry output will be 1. So here 1 plus 0 plus 0, the resultant is 1. So the sum is 1, carry 0. The next if you go with that 1 0 1, the resultant is 2. So you can't able to represent LSP. So the carry output is 1. The next you can go with the 2 the same way. So next if you add all that, the resultant will be 3. So the resultant will be 3 means both sum and carry will be 1. The reason is here it will be the 2 power 0 is 1, 2 power 1 is 2. So you add it both, you can get it the 3. So this is the truth table of full adder. Now the question is how to realize using 4 is to 1 max. The 4 is to 1 max, here the condition is not given. So you can choose either of these 3 inputs. You can choose any 2 as a selection lines. If condition is given, then based on the conditions you want to choose the selection lines. Now I am treated as the AB are 2 selection lines. That is for sum And similarly for the same, so I can go with that. This for carry. So now you can look at the truth table. The AB, you already have the idea. So the number of selection lines are 2. Then you have 4 possible combinations. The the selection lines combinations are 0, 0, 0, 1, 1, 0, 1, 1. Here that second one also same 0, 0, 0, 1, 1, 0, 1, 1. If you appear for any gate exams and all that, the combination is not given. So if you want to, by default, you want to go with this order 0, 0, 0, 1, 1, 0, 1, 1. Now if you look at that for the sum, first we will look at that sum, then later we move into carry. So when inputs are 0, 0, then you want to relate the sum with carry input Cin, or there are only the 4 possibilities. The 4 possibilities are either sum is 0 or 1, or it depends on Cin. So that is will be Cin or Cin complement. So here Cin is 0, sum is 0, and Cin is 1, sum is 1. So now it's very clear. Sum follows the input. Sum follows the inputs when inputs AB are 0, 0. So now it's very clear. So this one it will be written as Cn. The next, the combinations 0, 1. So A is 0, B is 1. What about my sum? So here you look at that. Cn is 0, sum is 1. Cn is 1, sum is 0. So now sum, it's not as it is Cn, but it will be the complement of Cn. So I can written as Cn bar. The next, if Cn is 0, sum is 1, Cn is 1, sum is 0. So as it is the previous case, so you can directly written as Cn bar. Now if you go with that, the last combinations 1, 1, the sum, so that is will be Cn is 0, sum is 0, Cn is 1, sum is 1. So it's directly depend on Cn. So whatever the Cn, that is will be my sum output. So now for this case, so sum is nothing but Cn. So these are will be the 4 data inputs for sum. So next, the same way you can look for how to realize carry, because the full adder, the output sum and carry considered as full adder. So now you can look at 0, 0. So you want to look at the carry. So now Cn is 0, carry is 0, Cn is 1, carry is 0. So whatever may be input, my output is 0. So it's not related to that. So you can go with the 0. The next 0, 1. So here the second selection lines are 0, 1. So 0, 1. Now you look at that. Cn is 0, carry is 0. Cn is 1, carry is 1. So now the carry is directly related to Cn. So whatever the Cn, that is will be my carry. So here I can written as Cn. The next 1, 0. So again the same. So here Cn is 0, the carry is 0. Cn is 1, carry is 1. So like the previous one, so you can directly written as Cn. Again, the last one, the 1, 1. So if you go with the 1, 1, so now you look at here, the Cn is 0, output is 1. Cn 1, output is 1. So whatever my input, either 0 or 1, the output is will be 1. So I can written as 1. So this is will be how to realize full adder using 4:1 max. So now I can redraw it for better understanding. So now you can, after realizing that using 4 is to 1 mux, you can cross verify that from the block diagram. So we can look at how to cross verify it. So the well known sum expression is for full adder A exclusive, B exclusive, C. So you can expand it. So you can get it C in bar into A exclusive B plus C in into A exclusive B whole bar. So this will be the expression of sum. So now we can verify it whether we can get it or not. So here 0 0, here is 1 1. So 0 0 1 1 will be written as A bar B bar. The first term is 0 0 and then the last term is 1 1. So here, because why we are considering the first term and last term means the data input is same. Data input is same. So that's why we are going with that. So A bar B bar plus AB into Cn. Then similarly, if you go with the second and third, so this will be A B. So here you can go with the A bar B plus A B bar. The data input Cn bar. Now A bar B bar plus AB is nothing but the two input exclusive NOR gate will be rewritten as the complement of two input XOR. So A exclusive bar into Cn plus A bar B plus A B bar will be written as A exclusive B into Cn bar. Now for simplicity, I can consider A exclusive B as X. So X bar Cn plus X Cn bar is nothing but X exclusive Cn. Now X is nothing but A exclusive B, then exclusive Cn. So this is will be the required one, the first one. This will be the first one. So our realization is correct. The similar way we can look at for carry. So now AB, that selection lines are 0, that first data input is 0. So anything it will be into 0, that answer is become 0. The next we can look at that AB or 1, then output is 1. So I can written as AB plus, then second and third the data input is same. So I can do with that Cn. For 0 1 and 1 0, so we will be knowing that 0 1 it will be written as A bar B plus A B bar. So the carry is AB plus Cn into A exclusive B. So this is our required carry expression and this is will be required sum expression. So it will be meet out the design. So this is what how to realize full adder using 4 is to 1 mux.